Hi. If you ever hooked up a new piece of gear into your setup and instead of lovely sounds heard this or this, don't give up. Whether the cause is a ground loop, some other interference, or air conditioning, there are often simple and cheap ways to solve this problem. Almost 7 years ago, I published a video with a few ideas and those still work, but since then, new products have come out and I've discovered even better ways to solve this problem. All of these have been shared over the years in my book updates on Patreon, but some of these are so good I wanted to share them here for free, and of course thanks to the patrons who support this channel. I'll also link to a checklist with everything including pros and cons of the various options when relevant below. Before I start, a quick disclosure, no manufacturer gave me anything in order to participate in this video. I either bought the gear you'll see, received it previously, or got it from stores I'll leave affiliate links to in the description. Buying using those links helps the channel regardless of the product you choose to buy. Okay, let's get going. Step 1 is to identify the source of the noise. For example, in this simple setup, noise could be coming from the synth's power, a bad audio cable between the synth and the mixer or audio interface, or the cable to the speakers. Try to identify the source first by disconnecting stuff. And then step 2 is a bit counterintuitive to step 1. If the source of noise is a ground loop, noise might not be coming from one particular device, but rather from the fact that 2 or more of the devices create a ground loop when plugged in. In this case, one simple thing that might work is connecting all your devices, including speakers and computer monitors, to one outlet or power strip. However, connecting everything to the same power strip doesn't always work. For example, if you're powering multiple effects pedals, a daisy chain style cable connecting all of them to the same big adapter might be a cheap solution, but can introduce noise as you power more pedals with it. In that particular case, if you do get more noise as you plug in more pedals, use isolated power supplies for your board, like Zuma from Strymon or those by Siox. If your device requires 110 or 220 volts, one solution you definitely should not consider is clipping the ground pin of your plug or using one of those little 2-prong to 3-prong adapters. That will work to kill the ground loop, but it's not the only thing it's going to kill. Ground is there for a reason, to prevent fires and electrocution. You could look into a rack-mounted power conditioner. However, since I made my first video, a company called Morley created this thing called Humno. It's got a standard IEC connector on both ends, which doesn't lift the actual ground, so using it shouldn't kill you. And I tried it and it actually does solve the problem, so I can recommend it. It does cost around $100 though, and only works with one device at a time, so make sure you try the less expensive options I discuss in the video before getting this one. There's another set of products which seem similar by a company called IFI. They make both a ground loop isolator and a DC blocker, which apparently is another source of hum. You can plug them into each other. I didn't buy them because Humno solved my problem and they're more expensive. And I also like the fact that Humno has extension wires on both sides so as not to put stress on the jacks in my gear. Okay, let's talk about cables. First, a common noise source could be bad cables or a bad plug or jack in your device. So try swapping out cables to make sure it's not the cable and wiggling the plug a bit in the jack to identify potential issues there. And then my all-time favorite way of solving noise issues is to use balanced cables. These are cables with 2 black rings on the plug as opposed to just one black ring. TS versus TRS, or use XLR cables with jacks or plugs that look like this. Now, it's not the cables that are actually balanced, but rather it's the gear that they're connected to. So these will only work when the gear on both ends supports balanced connections. The longer that regular TS cables get, the more likely they are to pick up noise and lose high frequencies, whereas balanced cables can work noise-free for hundreds of feet. So it's not really about the cable, but rather the connection. So for example, in this interface, the headphone output does accept a TRS or stereo jack, but this isn't balanced. Rather, it sends out 2 mono signals on a single cable. Cables like these connected to balanced outputs each carry a single mono audio signal and cancel out noise using phase inversion trickery. So you need 2 of these to carry a stereo signal. By the way, make sure you don't forget to use balanced cables with your speakers too, either TRS or XLR, it doesn't matter, and simply avoid buying speakers that don't have balanced inputs. If your gear doesn't support balanced audio, try to avoid interference by keeping your audio cables away from power cables and transformers, not to mention your cell phone or Wi-Fi router. And if you must have audio and power cross paths, avoid running those cables in parallel, rather keep them away from each other as much as possible. Let's move on and talk about another popular source of noise in an audio setup, and that's when you power a USB device from your computer and then run audio back into your computer or interface. So the first tip in that situation is simply not to power your USB device using your computer. Just get an external USB adapter or power brick, or if it comes with batteries or supports batteries, use those. Sometimes, however, you must have your USB powered instrument connected to your computer. For example, if you want to send it MIDI from your computer or to your computer, or if it has some sort of control software plugin you want to run on your computer to control it. In this case, we've got a few possible options. One option is to send your device MIDI through a different USB MIDI interface. I've found that connecting your instrument using 5-pin DIN MIDI prevents that nasty high-pitched USB noise. Another relatively inexpensive option is to use a USB splitter, something that separates power from data. Note that this is not a regular USB hub. This lets you power your device using an external adapter and send data back and forth on the other jack. This particular one was bundled with a KeyStep 37, and I bought this one from a company called IFI. You feed it power through here and connect your USB device into here, and this goes into your computer. And there's a better yet more expensive solution, which is this little guy. If you've got a budget to spend on amenities, the Topping HS02 has become a favorite for two reasons. First, it solves the USB noise problems that I've had without requiring a separate power adapter. You just connect it to your computer on one end and to your device on the other. And then second, because it lets you select either USB type using this switch on both ends. So this saves a bit of time hunting down the right cables. It is, however, relatively speaking, expensive. The thing is, I tried to buy all kinds of cheaper USB isolators that claim to do the job on Amazon and AliExpress. That didn't work for me, but that's just my experience. I'll add links in the description to other devices I've heard work well from people I trust. Finally, another interesting way to solve USB noise, increasingly modern instruments may actually have a built-in audio interface inside, meaning that they send audio over USB. You can pick that up in your DAW and hear and record audio that way, noise-free, without using the analog output. Another option that might help as far as USB noise is concerned is ferrite beads or chokes. No, these aren't for choking ferrets. Rather, they're supposed to help reduce electromagnetic interference impacting USB or network cables. I'm mentioning this in case you ever wondered what these things are on some USB cables, and you can buy these separately and add them. You need to loop the cable once and add it on top of the loop. Personally, I haven't experienced the kind of interference that these are supposed to solve, so I can't say how useful they are, but you can try it. Okay, let's move on. Up until now, I discussed various solutions that solve noise issues and have no negative impact on the sound of our instruments. There are a few other options for cases where what I mentioned doesn't work or isn't applicable for some reason or is too expensive. The first group of such products are audio-based ground loop isolators that you add to the audio signal path at the output of the noisy instrument. These can be anything from simple unbalanced dongles like these two to balanced isolators like these two. DI boxes with a ground lift do a similar job. All of these are passive devices, meaning they don't require any power, which is a nice perk. The only exception to this category is active DI boxes, which you'll use for passive audio sources like dynamic microphones or passive guitar pickups. However, there is a potential catch to all of these. They may impact audio quality with harmonic distortion and potential reduction in the lows and highs. Polarity of the signal may be inverted too, but that probably matters less. These work using transformers, and one might say that analog transformer harmonic distortion is desirable, but you should know what's going on. My experience is that it depends on levels. Coming in too hot may cause unpleasant distortion, but otherwise these are inexpensive and work great, and the difference can be inaudible. So it's definitely worth it to have these around if the other solutions don't work or are more expensive. If you're asking which of these to get, it's a combination of features and potential impact on sound quality. On the feature set side, some have 3.5mm jacks and some have either 1/4" or XLR jacks. These handle stereo unbalanced signals, whereas these handle balanced signals, and you can see a few feature perks on them, like a pad option. These will also convert an unbalanced signal into a balanced signal. On a side note, another benefit of these transformer-based products is protection against having your equipment damaged by accidentally plugging in your instrument into an XLR jack with phantom power on. Moving on, guitars can create their own special kind of noise. This isn't a guitar channel, but let's just say I've dabbled, and what I've found is that some pickups and pickup combinations on guitars are noisier than others, and there's a reason they call some pickups humbuckers. Another thing that helped me with guitars was using a wireless transmitter like those from Roland or X-Vive. Since guitar audio cables aren't balanced, they love picking up interference, and some of these companies also offer wireless solutions for microphone and line level products. Moving on, if you need to move audio around very long distances or balanced cables aren't an option, consider using network-based audio solutions like AES67, which is open source AVB, which requires specific switches, or the proprietary Dante, which works with regular switches. There are a whole bunch of these solutions that take network cables on one end, very long ones if you want, and spit out or take in audio on the other end. Then finally, if it's too late to fix noise issues because you already recorded audio with noise and re-recording isn't an option, you can try to fix audio issues in post. For example, with USB type noise, it's often a set of high-pitched fixed frequencies ringing out. In this case, a simple notch filter can take these out without causing much damage to the rest of the frequency spectrum. If it's a noise or hum that affects a broad range of frequencies, there are both free and paid tools that help extract noise from recordings using advanced algorithms. The free Audacity lets you sample a small portion of the recording where you only hear the noise you're trying to get rid of, and then use that to apply noise reduction to the entire recording. If that doesn't work, try the paid RX from Izotope. It's not cheap, but still cheaper than a time machine. If you're familiar with other good tools, please let us know in the comment section below. So that's it for now. I'll leave a link to a summary of all these solutions below, and if you don't want to wait 7 years for the next video, I'll put anything else I learn as I go along in my ever-expanding book of electronic music ideas, tips, and tricks available on my Patreon. Hit like if this was useful. Ring the YouTube bell below if you want to make sure you don't miss the next one. Thanks for watching.